The second thing that we need to be able to do so that we can get our marks in our exam is to be able to solve quadratics. There are many ways in which you can solve a quadratic, depending on how complex it is or depending on what paper you are solving it on. If it's the non-calculator paper, it's more than sure that you have to solve the quadratic by factorizing it. So I think that the easiest method to solve a quadratic is by factorizing it, if you remember how the process works. So let me give you an example. I will put some examples on the board for you so that you can solve them with me. There are some easy questions. For example, x squared minus 7x. So we can even write them down. X squared minus 7x equals to 0. As soon as you get this question, you know that you can factorize it very quickly because you have two terms here and there is a common factor in both of them. X appears in both of them. So you can factorize it by x brackets x minus 7 equals to 0. Therefore, there are two possibilities. Either x equals 0 or x minus 7 equals to 0. Therefore, x equals to 7. That's the easiest quadratic I can think of to solve by factorizing it. So that would be the first example. The next level of factorizing a quadratic, let me give you another example, is this one. When you have something like this one states that p squared plus 6p plus 5 equals to 0. So what you need to do now, you need to look at the constant here, this 5, and think about some factors of 5. So 5 could be equal to 1 times 5 or to minus 1 times minus 5. So because 5 is a prime number, actually, there are no other factors of 5. But if you, instead of 5, you would have had a different number like 12 or 24 or 36, whatever, you could have made a list and then you would have chosen the pair of factors that satisfies your needs in this case. So here it says that the coefficient of P is 6. It's a positive 6. So I need these two factors to add up to 6. So whatever factors I've multiplied and I got 5, I need them to add to 6. Then I can open the brackets and I can write down, because I found the pair, 1 times 5 is 5 and 1 plus 5 is 6. So it's definitely these factors. So I'll put down that p plus 1 times p plus 5 equals to 0. Well, you can even check. If you don't believe me, you can check. You see, so when you expand these brackets, you will end up with exactly that expression or that equation there. So if p plus 1 times p plus 5 equals to 0, so there are two possibilities here. It's either p plus 1 that equals to 0 or p plus 5 that equals to 0. So if p plus 1 is the one that equals to 0, then you'll have that p equals to minus 1. So that's your first solution. And if this is the case, then p equals to minus 5. So this is your solution. This is the second level of factorizing quadratics, and this is usually for foundation paper, but it might be the case that in the higher paper, you might have factorizing quadratics that are a bit more complex than that. So let me give you one example. Let's look at this one. They even specify that you need to solve by factorizing it. That means that they are checking if you know the method or not. It's not just that you need to be able to solve a quadratic, but you have to be able to know all those 4 methods of solving a quadratic and apply the one that's the most efficient in your case. So let's look at this equation here. It says solve by factorizing it. So how we will do it, this is how we will do it. It's a bit similar to what we've been doing before, but this time you will do this. You will times 6 times minus 25 So you will do 6 times negative 25, and this will obviously give you a negative number, which is 150. So negative 150. And then you have to think about two numbers that you multiply to give you 150, and then you add to give you 5. So what numbers do you multiply to get negative 150? And you also add to get 5. Two numbers that have this difference between them. Obviously, for me, it's very easy to see now. It's 15 and 10, something around that. But is it negative 15 times 10, or is it 15 times negative 10? That's the question. Well, because 5 is a positive 5 there, it's definitely going to be 15 times minus 10. Because when you add these two, 15 plus negative 10, you will end up with 5. So this is the pair that I'm looking for. Now I'm going to use this pair of numbers to rewrite my equation. So I will rewrite this and I will prepare it for factorizing, okay? So I will rewrite it as 6n squared plus 15n minus 10n, then minus 25 equals to 0. So you see how I converted this. I have rewritten this as this. You see? So my 5n became 15n minus 10n. Why did I do that? I did it because I wanted to find a way to factorize pieces of this equation, if you want to say so. Okay, so let's look at the first one here. 6n squared plus 15n was the common factor here, first n, and then also 3. So 3n goes into both of them. Let's factorize them. 3n times 2n plus 5. And then I will try to manipulate the next bit in such a way, it will be easy to do it, but I have to make sure that I manipulated it in such a way to end up with 2n plus 5 on the other side as well. So I will do minus 5, and because I pulled the minus 5 in front of the bracket, I can say that instead of 10, I will be left with 2n, and then instead of minus 25, I will have 5 equals to 0. What do I have here? I have two terms, this term and this term, that have a common factor, but the common factor is not a number or a variable. It's not just a constant or a variable, it's a full bracket. So the common factor became a full bracket. Therefore, I'm going to say that 3n minus 5 times 2n plus 5, so I've just factorized by that bracket, equals to 0. Again, I have two possibilities here. It's either 3n minus 5 equals to 0 or 2n plus 5 that equals to 0. If this is the case, then n will be equal to 5 over 3. And if this is the case, then n will be equal to negative 5 over 2. And this is it. These are the roots of my quadratic equation. This would appear in extended paper or in a higher paper if it will be the case. So that's only one method. The second method is completing the square. I will show you that a bit later. The second method is completing the square. This is one very easy example. This method is also very important because it helps you find the turning point. So when you complete the square, you are basically referring to that formula that states that a plus b squared equals to a squared plus 2ab plus b squared. So you are just trying to manipulate this expression into this to make it equals to 0, so then you can figure it out. You can actually, so you want to leave the constant outside the bracket. This is what we will do. Instead of 8a, I will rewrite it as a plus 4, everything squared. So I just made this bit, and then I will take away whatever I've done wrong there. It's not a plus 4 squared, because if I would have done it that way, it would have given me a plus 8a plus obviously 16. But it's not that. It's a squared plus 8a plus 11. So I can't say it's that. So therefore, this is what I'm going to do. I'm going to do a plus 4 everything squared. Then I will take away the 4 squared, that's 16 that I don't have there. And then I will add the 11, and that will equal to 0. So it will be a plus 4 squared minus 5 equals to 0. Therefore, I can rewrite it as a plus 4 everything squared equals to 5. Therefore, a plus 4 will be root 5. So a will equal to either minus 4 plus root 5, or a will equal to minus 4 minus root 5. And this is very, very interesting, because you see, this root 5 can be a positive or a negative number. Do you remember that any number, if you square it, you'll get a positive number, even if the number is positive or negative? Let's look at a very easy example. 3 times 3. So that would be 3 squared. 3 squared equals to 9. But also negative 3 squared will equal to 9. Therefore, we can say, especially in these type of questions, right? It's definitely a mathematical truth that root 9 can either be 3 or minus negative 3. Both ways. It goes both ways. Okay, so in this case, we will have that these are the two roots of our equation. Okay, let's take another example and see how it goes. In this case, we will just half 20. So we will rewrite it as x minus 10, everything squared. So we made it look as if we were trying to square this bracket, but if we do it that way, what will we end up with? We will end up with x squared minus 20x. All good up to here, but then it will be plus 100, which is not the case. It's just plus 64. Therefore, I need to get rid of this 100. So I'll just write minus 10 squared plus 64 equals to 0. So it will be x minus 10 squared minus 100 plus 64 equals to minus 36 equals to 0. Therefore, x minus 10 everything squared equals to 36. Therefore, x minus 10 will equal to either 6, or, because root 36 is 6, or x minus 10 will equal to negative 6. When x minus 10 is 6, x will equal to 16. And when x minus 10 is minus 6, x will equal to minus 6 plus 10. And these are the roots of your equation. So this is the second method. We will discuss about the next method in a minute.